A heterotrimeric protein consists of 3 subunits with molecular weights of 10, 40, and 100 kilodaltons respectively. The protein is denatured with 3 molar urea and subjected to size exclusion chromatography. Which solute is the last compound to elute from this column? So this question is testing our knowledge of how size exclusion chromatography, aka gel filtration chromatography, actually works. And the way that it works is you have a column, and in this column you have a bunch of these beads, which is the solid phase. And these beads have these little pores, okay? And if we zoom in on one of these beads, the pores have a particular size, right? And basically anything that is smaller than the pore size can get into these pores and get stuck in the bead, right? Whereas anything larger will not get stuck and it will move through the column faster. So basically the smallest solute is going to be the one that is retained the longest in this column, and it will elute last. So amongst the protein subunits, obviously the 40 and the 100 are going to leave first. The 10 kilodalton amongst the proteins here is going to elute last. But notice that they're trying to trick us because they include urea, which is actually what you're using to denature the proteins, as an answer choice. And urea is going to be really small. It's going to look something like this. This is basically urea. All right, so that's super small. It's going to be smaller than any, protein or peptide in this column. So actually, among all of these solutes, the urea is going to get retained the longest, right? Because if any of these pores is big enough to fit a 10 kilodalton subunit protein, it's certainly big enough to fit a urea molecule, right? So this is going to get retained the longest.